Hey, this is Step Amit. Welcome to my exorcism.io series. In this video, I'll be working through the pangram exercise from the exorcism.io Ruby track. Now, a pangram is a sentence that contains every letter in the alphabet at least one time. The most famous example of that is the sentence, "The quick brown fox jumps over the lazy dog." And so in this exercise, we're going to be given a sentence and we have to determine whether or not it is indeed a pangram. So we'll go ahead and copy this. Create a new TMX session. And I'll go ahead and open up the test. All right, so I've got a pangram class that has a single class method, pangram A, that takes a sentence, and this question mark at the end here, the A, tells me that by convention, this is going to return truthy or falsy. That's also how we're testing here: expected false, expected true. And that looks like the only method we have. So the first one, an empty sentence, should return false. That should not be a pangram. Okay, so I'm going to go ahead and open up my testing pane, run my tests, and it'll fail because the file doesn't exist yet. So let me go ahead and create that pangram.rb. I'm going to reverse my panes here so that my class under test is on the left and my tests are on the right, and run it again, and it's going to complain because I haven't initialized the class yet. Now it'll complain because I don't have a class method named pangram yet. Okay, yep, undefined method pangram. So let me go ahead and create that method. So now it's going to complain because I'm not accepting any arguments there, and it expects me to accept at least one. Right. So let me add that. And now I think we're going to pass because this returns nil, which is falsy, and my tests are green. So I'll go ahead and move on to the next test here. This one is going to pass. So perfect lowercase pangram. It's literally the lowercase alphabet. This is going to fail because we're returning nil, which is falsy, and not true. So I'm going to have to go ahead and implement this now. Right, expected true got nil. So how do I determine whether or not this input is a pangram or not? I suppose there are any number of ways that we could do this. We could simply look at every character and keep a count of each letter and shove those into a hash or something, and then in the end, count up how many we have. And if we've got 26, which is the number of letters in the American English alphabet, then then I know I have a pangram. I don't know how else. There's probably even more ways that we could do it. But what jumped to my mind right away when I saw this was array math. So in Ruby, you can do simple math with arrays, and the main thing I'm thinking of is subtract. So if I have an array here, let's pretend this is my alphabet. Numbers 1, 2, 3, 4, 5. Just pretend those are the letters of the alphabet. I can subtract another array. So if I have an array that contains 3, what's going to happen is the contents of the second array will be removed from the first array. So I get 1, 2, 4, 5. And so again, if I've got a 4 here, or let me do it backwards. If I have a 2 here, then my array on the left will be 1, 4, 5. Even if it contains something that's not in the original array, it doesn't matter. It's just going to subtract elements that are present in the left-hand array. It's going to subtract those things. If I subtract every element, then there will be nothing left. And what I can simply do is take the results of that array math and ask whether or not it's empty. Because if the remaining characters, if that resulting array is empty, then I know that whatever is on the right side of that equation is a pangram. It does indeed contain every element from the left array at least one time. However, if there's one element left over, then false. It is not a pangram. So this is how I'm gonna solve this. So what I need on the left side here is I need the alphabet as an array, and the way I'm gonna do that is simply to create a range from A to Z, all lowercase, and simply call 2A. That will give me my alphabet array. Then I need to take sentence and get, I need to take the sentence and turn it into a character array. And, you could split on an empty string, but what I think is even more intention revealing than that is to use the chars method on array, on string, the chars method on string, which will give you an array containing each character. We want to go ahead and now simply inspect the results of that math to see if it's empty, and this should now be green. What did I do? Oh, too many closing parentheses. All right, that's green. And let's see. Test pangram with only lowercase. Yep, that's going to work because that's exactly what we're doing. Test missing character X. If it's missing an X, it should not be a pangram. That's going to work. Test missing character H. Same thing. That's going to work. Test pangram with underscores. Our algorithm doesn't care about underscores. This is going to be just fine. Test pangram with numbers. Same thing for numbers. I don't care about numbers. Missing letters replaced by numbers. I don't know why any solution would not work for this. That seems like if you implemented a LeetSpeak savvy algorithm, then you would be out of luck. You would not be matching. You wouldn't be meeting the requirements. All right, test pangram with mixed case and punctuation. All right, this is going to fail because we're expecting our input to be all lowercase, but even though that's going to fail, that is really easy to solve. We just need to downcase our input. And now we have a case insensitive pangram check. Okay, test upper and lowercase versions of the same character should not be counted separately. Okay, this could be a problem if we were doing the first thing I mentioned, the first solution where we simply maintained a count of every letter and then just checked how many letters do we have. Do we have 26? Because lowercase and uppercase letters are actually different characters. And so that would really complicate that solution. But my solution here doesn't rely on that. And so we have all the tests passing. Cool. Okay, but I don't want to leave it like this. I want to refactor this into something that I'll be happy to see in 6 months when I come back. I don't want to take however long it would take, not very long to untangle this, but I just this code could be a lot clearer and a lot more explicit. And so in order to refactor this, I'm going to want not a class, I don't want to work with class methods. What I want to do is I want to have an object that has some state and knows how to do things in a clear way. So the first thing I'm going to want to do is actually push this functionality down into an instance of my class. So let me get rid of that. I want to new up an instance, giving it my input and calling the same name is generally how I do this, as my class level method, as an instance method. And I'm simply going to paste that code in here that I had before up here. This, of course, isn't going to work as is. Well, first, because I need to define an initialize method that takes an argument. And I'm going to go ahead and set an instance variable. And, this is still not going to work, right? Because I'm looking for something called sentence here. It's not available. I don't have a local variable here called that. And while I could do that and simply look directly at the instance variable, what I'm going to do instead, this is what I tend to do. I want to create an adder reader. And now I don't have to change line 15 for that. And what I like about this is now this method, it doesn't have to know much about the implementation of sentence. Like where does sentence come from? It doesn't need to know that it's an instance variable. And for instance, if there was some reason I needed to do something else with sentence, I needed a method that, went and got it, or memoized the value, or pre-processed it, or whatever. I want that to be hidden from pangram A. Pangram A has no business knowing where sentence comes from. So by doing it this way, I can keep it from knowing that. Now it does add sentence to the surface area of my class as far as what the outside world sees. So maybe I would want this to be private, but I'm just going to leave it as is for now. All right. So what's next? Let me read this going from the outside in. I'm asking pangram.pangram sentence, is this sentence a pangram? And the way I determine it is I'm going to create a new instance, and ask if it's a pangram. All right away, I see that this is not really what I would call this. I think I really want to call this valid A. And so that breaks kind of my normal convention of a class level convenience method calling an instance method of the same name. But I think it's a little bit more explicit that what I'm doing here and asking is this a pangram? Is I create a new instance and I ask, is this valid? That makes a lot more sense to me. Cool. Okay. And so what does it mean for it to be valid? Well, I mean, all this junk here. So most explicitly, so this really gets to the heart of what is the definition of what a pangram is, right? Is this a valid pangram? Well, I mean, it meets the definition of a pangram. If it does meet it, then it is. And, I think early in my career, I might have been tempted to reach for a comment here to explain what a pangram is. A pangram, a pangram is valid if it contains the entire alphabet or something like that, or every letter in the alphabet. And then I would have probably left this code like this. The problem with this, and this is why people have an aversion to comments, is that comments are stale, right? Comments get stale. Somebody's going to come in here and change what this means or change the definition, and they're not going to update the comment because the comments don't make any test fail. So they get out of sync, right? So what I want is self-documenting code, right? I don't want to have to add a comment. I want it to be explicit and clear when I look at valid A, what that means. Well, it means it's valid if it contains the entire alphabet. I want to literally be that explicit about it. And so I'm simply going to move the previous contents of that method to a private method called contains entire alphabet, A. And now when I read this, I mean, this is pretty clear, right? Is this a sentence a pangram? Well, let me create a new one and see if it's valid. What does that mean? Is it valid? Does it contain the entire alphabet? See how clear that is? I don't have to be a programmer to read that and understand it. So let's keep going. What does it mean? How do I know if it contains the entire alphabet? So again, working top down, I'm going to look over here and see that the last operation here, the last question is, does everything over here, is the result of everything inside these parentheses empty? All right, so what is the result here again? Well, this is our array math, where I take the alphabet and I subtract my sentence from it, the letters in my sentence, and I want to know if that is empty. So I'm going to call that remaining alphabet. Is the remaining alphabet empty? And simply paste this in here. I can get rid of the surrounding parentheses there. The remaining alphabet. Cool. So what is it? Is it valid? Well, does it contain the entire alphabet? How do I determine that? Well, I look at the remaining alphabet and ask whether or not it's empty. All right, cool. So how do I determine what the remaining alphabet is? Well, I take this unnamed thing over here and I subtract this unnamed thing over here, the sentence downcase chars. I want to give these pieces a name so that it's easy and it's clear. And this on the left side, of course, is the alphabet. So I'm going to put that in a constant. And so why do I do that? Well, so let's look at it this way. Right now, the remaining alphabet method is actually doing three things. One, it's responsible for generating an array of every letter in the alphabet. It's also responsible for taking our input sentence and converting it to an array of characters. And it's also responsible for subtracting that array from the alphabet array. See, it's doing three different things. It violates the single responsibility principle. And anytime a method or a class has multiple responsibilities, it's harder to understand and it's harder to change. It's harder to maintain because, there are three reasons why this piece of code could change. And I don't want it to. I want it to be I want it to know as few things as possible. Remaining alphabet has no business knowing where the alphabet array came from or how it was created. So, there's lots of ways we could have generated this alphabet array. So I'm simply going to extract it by giving it a name. And I want to do the same thing on this side here. Sentence downcase chars. I'm going to call that the sentence characters. And I generally like to split these things onto multiple lines so it's clear that I'm taking my sentence, downcasing it, and getting the chars. Now, I could see moving this downcase to actually the initialization. I think that's a fair thing to do. And then really I'm just getting the chars. Now I can just put it on one line. I'm comfortable putting that on one line. What happened here? 27. Sentence sentence characters. There we go. I hadn't run my test. But even this, it's like, well, what am I doing? Why am I downcasing sentence when it comes in? This can be a little clearer too. Really what I'm doing is I'm normalizing it, right? I'm taking whatever I was given and I'm normalizing sentence. So let me add that. And this is going to now contain that sentence down case. So now, oh, I spell it wrong. Normalizing. I spelled it wrong. So now this is much clearer to me, right? That like, why am I downcasing it? Well, I've got to normalize it. So I normalize it on new. Okay, so once again, let me just read this from the top down. All right, pangram, starting over here. Pangram, is this a pangram? Well, let me see. I'll create a new pangram and I'll ask if it's valid. On creating a new pangram, I'm going to normalize my input, which right now, the only thing it does is downcase it. I could do something else with it, but I'm going to downcase it. Okay, cool. So what does it mean for it to be valid? Well, does it contain the entire alphabet? All right, how do I determine if it contains the entire alphabet? Well, the remaining alphabet is empty. Cool, what's the remaining alphabet? I take my alphabet and I subtract the sentence characters from it. All right, how do I get sentence characters? I take my sentence and I ask for the characters. You know, this could, you know, sentence.chars. You know, I wouldn't bark if this was here. That's actually pretty clear to me, but you know, it's pretty simple. But I think I'm going to leave it like that. And then again, the only other piece of knowledge here is the alphabet and how we get it. You know, we could also take literally just take this string right here that contains every letter in the alphabet and get the chars from that. You know, that would be equally valid as doing it this way, which is exactly why I don't want the remaining alphabet method to care about it. All right, anyway, I think this is pretty clear. I like it. I'm going to go ahead and submit it. And I'll see you in the next video.